All right, here's the agenda. Okay, so okay, perfect. So we have a few contributions to agenda from Antonin and Jean-Jun. So I think we can.
So, Ettore, sorry for interrupting you. Do you plan
Yeah.
to share your screen or?
No. I mean, I was just looking at the mailing list, so nothing,
Okay.
nothing major. So the first item that we have into the agenda for today is an introduction to the OVS pipeline implemented by Antrea by Antonin. So maybe, Antonin, are you ready? You want to? Okay, perfect.
Yeah,
Let's go.
I'm gonna share my screen and just I think walk through my pull request, and
Perfect.
that's gonna be recorded. So if somebody wants to learn more about the pipeline, they can refer to that video later.
Actually, I don't know if it is with you, but it shows that this session is recorded 3 times. Hopefully, it will work.
It is recorded one time. Basically, you see one cloud with the recording for everyone with who's a host or a co-host.
Okay.
Because
Cool.
they are the users with the power of starting or interrupting the recording.
Okay, thanks.
All right, so hopefully everyone can see my screen now. So this is a pull request I opened like a couple days ago, and it's going through a review right now. And basically, when I started working on Antrea, well, I found it like a bit confusing to debug stuff without knowing exactly what the pipeline was doing. So I took a couple days before OBSCon, and I documented the pipeline. It was like killing 2 birds with 1 stone, because I was able to talk about it at OBSCon as well. So I did that diagram of the pipeline. I think I'm just going to cover, it's about a dozen tables. I think I'm going to cover all the tables one by one, and show some example flows, and so explain what they are for. And obviously, if you have questions on this, just interrupt me and we can make it interactive. So the first table on the pipeline is the classifier table, and it's very simple to understand what's going on here. Basically, we match on the ingress port for the packet, and we write to one of the registers supported by OVS. We use like 16-bit of the first register, register 0, as you can see here. We write an integer value to classify the traffic in 3 categories. So we have local pod traffic, local gateway traffic, and tunnel traffic. So tunnel traffic is everything that's coming from a remote Kubernetes node. And we're going to use that information later in subsequent matches in other tables of the pipeline. And I think we're making a few changes at the moment right now, so that actually if there is no matching ingress port, that probably means that there is something wrong going on. And so we're just going to drop the packet. We should not have like a miss here. So I think instead of just doing a resubmit, we're going to replace that by a drop. And the normal action here is just something which is installed by default in OVS to say that, okay, if you don't have any tables defined, any flows installed, basically you do the normal action, which just means like traditional forwarding. It makes it behave as a Linux bridge, basically. So the next table is the spoof guard table, and so it's just here to prevent like IP and ARP spoofing, basically from local pods, in case one of the local pods is misbehaving. And so what that means is for every pod, we're going to install 2 flows, one to prevent like IP spoofing and one to prevent ARP spoofing. And if we look at those 2 flows here, I mean, flow number 3 and flow number 5 here, those were installed for one of the core DNS pod. And so the first one is for IP spoofing. Yes, and basically the way it works is If none of the flow matches, sorry, I should have started with that. If none of the flow matches, then it means it's a spoof packet and we're going to drop the packet. If one of the flow match, then that means it's a legit packet. And by legit packet, it's either it's a correct R packet or it's a correct IP packet. And we also use that table to basically separate traffic, split traffic between IP and HARP. And if I scroll up in the pipeline here, you see that we're going to go to two different next tables based on the type of traffic here. So pretty straightforward. I think we had a discussion a while back that we don't have any checks for the gateway. And that's because there is no guarantee that traffic coming through the gateway is going to have as the IP source, the IP assigned to the gateway interface. And that's because service traffic, for example, is going through the gateway. And for that traffic, the source IP is original pod IP. Yeah, did I see that? No. Yes, that's correct. That's correct.
We have a issue, I believe, issue 200 open to put some sort of spoof guard on the gateway, right? To make sure that at least we only have we don't allow all the sorts of source traffic from the gateway interface, because I think there is a way for doing some sort of spoofing, like doing SYN flood attacks or something like that at the moment, but I don't think that it is an attack vector that can be easily exploited, because you first need to gain access to the container host, and even attacker has access to the container host. I think that they will do much more damage than a SYN flood attack.
Yeah, and I think the issue 200 you're referring to is,
yes.
I suggested that we added like the ARP spoofing check for the gateway interface regardless, because it was kind of like free to just do that.
That's right. That's right.
Yeah,
I mean,
even though you probably have bigger problems if this happens, at least, I mean, that's just like, you ensure that you cannot disrupt networking for other pods. I agree, you probably have other problems. But...
Yes, you can probably kill the pods themselves, but at least you don't disrupt networking.
Yeah. All right, so for ARP traffic, what we do next is we go through the ARP responder table. And here we really just do two different things. So if you look at the flow table, I think we should be able to remove flow 2 actually from the pipeline, because we guarantee that only ARP traffic comes here. But I guess it's good to have like a default action, which is just drop the packet. So there's no harm in this. So we do two different things. For most ARP traffic, we just do the normal action. And as I said before, it just means that the OVS switch is just going to behave like a normal regular L2 switch. So we're just going to do L2 forwarding on the packets like ARP replies. However, we have a special flow for ARP requests we have a special flow for ARP request where we're asking for the MAC address associated with a remote gateway. So I think I should clarify the documentation here. We actually, no, that's correct. We add one such flow every time a new node is joining the cluster. And so why do we do that? That's because we use a specific MAC address. We call it the global virtual MAC for all the tunnel traffic. Every node for every other node in the cluster is going to have that kind of route installed in the gateway, which basically tricks the Linux kernel into thinking that we're direct neighbors with the remote gateways, and that's a non-link route. And so that means that the host, when it has to send traffic to that remote gateway, is going to ask for the MAC address of the gateway using an ARP request. And so what we're doing is we just capture those ARP requests locally in the vSwitch, and we reply with the global virtual MAC. After that, the OVS switch is going to just send the traffic on the appropriate tunnel. We're going to see that in a further table. And when the traffic gets to the remote node, to the OVS switch instance on the destination node, the traffic is going to be decapsulated. We're going to identify the traffic by that global virtual MAC, and we're just going to forward it directly to the pod, to the appropriate pod, without first going through the gateway. So yeah, that's basically the special case we have here for HOP request for remote gateways. So that was for ARP traffic. For ARP traffic, the pipeline basically ends here because for everything else, we use the normal action. However, IP traffic goes from the spoof guard table to the contract table. And here, we just basically, we call the CT action on every IP packet to basically get the state of the connection here. And I think in the next table, what does the next table do?
That's a contract state, right? It's the state, sort of state flow for contract, right?
Yes, yes. We do something very specific. Yeah, we have a flow here, and that's the first bullet point, which is a bit hard to understand. And actually, that's changing a bit in the current code. There is an open PR for this. But basically, what we do here, the main purpose of that flow, I mean, obviously we commit all the new connections so we can have like a stateful matching on connections in the rest of the pipeline. But the main thing we do is if you have a pod sending traffic to a service, so that traffic is going to go first through the gateway where it's going to be handled by the queue proxy data path. And then we're going to pick up, it's going to load balance the traffic and select a backend pod for the service. And so let's assume that the backend pod and the pod which is originating the traffic are on the same node. Then when the backend pod replies to the originating pod, if we don't install that flow, then we're just going to do like L2 switching back to the originator pod. We're not going to go through the gateway for reverse traffic, and we're not going to go through queue proxy and IP tables. And so the packet is actually going to be incorrect because it's not going to have the correct IP address when it's received. It's going to be like the packet pod IP instead of the service IP. So you kind of need to do that reverse translation by going through IP tables. And this is what this flows is about. And takes care of that by overwriting the destination MAC address. So we don't do L2 switching. That happens before the L2 switching part. And we replace it by the MAC address of the gateway. Yeah.
That will be flow number 3 in this in the list on the page, right?
There are two flows. Flow number two is saving the MAC address into a contract register using CT label. Here you have a move from the source MAC address to the CT label. And flow number 3 is just in the reverse path, basically. If that's why we match on not new connection here. And we also match on the traffic mark that we put here. We mark it with 20 and then we match on that mark. So in that case, we move back from the CT label, contract label to the destination MAC address. But what I told Wenying is we should probably, we don't need that. We don't need to use CT label at all because we know what the MAC address is going to be. We know what it's always the MAC address of the gateway. It's not like it's dependent on the connection. So actually she's removing the use of contract label. Maybe we'll save a few cycles per packet or whatever, because we just don't need to do that save. We can replace the move here by a load operation using the constant MAC address of the gateway.
Antonio, the flow 1 and 3 in this, they both are for the tracked connections, right? So the first flow will always be a hit, correct? So will the third flow ever be, will we ever reach flow number 3? They both are for track connection and new not set.
Yeah, here we match. Here we do a match on register 0, right? So yeah, and it must be 1. I don't remember what 1 is. If I didn't put it, I should probably put it. Oh, it's for local gateway, so it's only going to be for the local gateway traffic.
I see.
For traffic coming from pods, which is what we're interested in for that thing that I just described. we're gonna hit the second flow.
Sorry, the first one is from traffic coming from pods, return traffic from pods.
No, the first one is for connections. It's for established connections where the packet is coming from the gateway. Because register 0 is set to 1 only for.
No, it's just that I was sorry. I must be confused. I thought that you said earlier that the third one was for return traffic coming through the gateway. Or sorry, do you mean the third one was for return traffic coming from a service cluster IP, from a backend pod for a service cluster IP? Sorry. Okay.
So flow 2 is also going to be for packets coming through the gateway, but it's the contract state here is different. So that's going to be for new connections. This one's for new connection,
okay.
For established connection. We coming through the gateway for service traffic after the load balancing happens, and that's when we need to save.
Okay, that makes sense now. No, sorry, I make confusion between cluster IP and gateway, but it's clear now.
So our next table is very simple. So it's going to take 2 seconds. And I was curious about what it was, so I asked Wending, and we talked about this. So there is a single flow, and what this says is, if this is cluster IP traffic, just output it to the gateway and don't do anything else. Keep the rest of the pipeline. And so you can read through the text here, but basically this ensures that we don't drop traffic because of an egress policy rule at this stage. If the traffic needs to be dropped for some reason, we'll do it after we've load balanced and after we've done DNAT on the packet with kubeproxy. Because for all that traffic anyway, we're going to come back and go through the entire pipeline again after kubeproxy has done its work. And I think the plan is also to use this very same table when we start implementing kubeproxy functionality in OBS. All right, so then we get to something a bit more difficult, I guess, which is the tables that we use to enforce network policies. So at this stage, we haven't done forwarding yet, and we're going to just enforce the egress roles of network policies, and we do the ingress side of things after forwarding. So the tables are very similar in spirit. We do conjunctive match fields, which is an OVS feature to avoid an explosion of the number of flows as we increase the number of network policies and the complexity of network policies. And there will be a separate document that Chan and I are going to work on to describe exactly how we implement network policies and translate a network policy into OVS flows. But here we can give a high-level overview. Basically, we use 3 dimensions for the conjunctive match. And the way it works is that those 3 dimensions are actually 3 sets of values. And you're matching 3 fields against those 3 sets of values. And if you have a match for each one of them, then we select that conjunction action and we perform that conjunction action. And the 3 dimensions here are the traffic source, where is the traffic coming from? Wait, no, I'm ingress. So yeah, where is the traffic coming from? Which is like the pod originating the traffic, which is the pod on which the network policy is applied. Then we have the traffic destination, because this is an egress rule. So are we allowed to send traffic to that destination pod? And then we have the port, the application port, basically. Sorry, the TCP port.
Yes, every time I look at conjunction matches, they always look different to me. It's they're not. It takes time to digest how they work.
Yeah, and so I have an example specification here, which is pretty simple. It says that if a pod has Nginx app label, then we apply an ingress policy rule and an egress policy rule. And those rules are the same. They say, basically what those say is that Nginx pods can talk to each other using port 80. So pretty straightforward. And if we look at the rules, those 2 IP addresses that show up here, 10.10.12 and 10.10.13, those are the two IP addresses for the two pods which have the Nginx label on my local node on which I'm dumping those flows. And so this is very kind of like easy to read. If the source IP address is one of those two IPs, that means traffic coming from those local pods. And if the destination is one of those two IPs, that means I'm talking to an Nginx pod. And if the port is AT, then I'm going to take conjunction ID 2 and resubmit to table 70. Resubmit to table 70 means basically I have no violation of an egress policy rule. However, if I have a miss, then I go to table 60, which is egress default table. And what that table is for is to enforce the default isolated pod behavior of Kubernetes. Basically, I mean, probably everyone knows that already, but in Kubernetes, if a pod doesn't have a network policy applied on it, it's a non-isolated pod, so it can talk to everyone, everyone can talk to it. As soon as you apply one policy, it becomes an isolated pod. And so now you have to have an explicit whitelist rule, for traffic to be accepted. And so the first table here, table 50, egress rule tables, basically is just like a list of whitelist rules. And table 60 enforces the default behavior. If nothing matched in the previous table, and if our pod is an isolated pod, which has a network policy applied to it, then we drop the traffic. Here are two isolated pods or Nginx pods.
That's done in a per namespace?
There is no notion of namespace here anymore. But I mean, yeah, network policies are at the namespace level. Maybe you want to clarify the question, or?
The default is only being, you said if a policy was applied, right? So if I have a namespace that there's no other network policies applied, then we don't do the drop, correct?
I'm gonna have to check with.
Yeah, in that case, we wouldn't drop because I think we are using the IP addresses here. So
okay.
Yeah.
Sorry, can you repeat that again, Abhishek? I didn't.
Oh, since we are using the IP addresses here to drop, so we are only dropping traffic for the pods which are isolated, and not really a CIDR or as such. So we should be good.
Yeah, you wanted to say something, Salvatore?
No. I was just saying. I was just going to say that's good. Let's move forward.
Yeah, and then I'm gonna go over this like very quickly. This is just like L3 forwarding table, so that's where we take care of tunnel traffic, which is destined to a local destination, and this is also where we take care of traffic which is destined to a remote destination by just like encapsulating it and sending it to the correct endpoint. And so we just use flow-based tunneling in OVS, and so we just add one tunnel flow every time we get a notification from the API servers that a new node has joined the cluster. L2 forwarding calc table is also like very straightforward. If you're familiar with regular switching, it's just what you would call the destination MAC table in pretty much any other switch, except this one is populated like statically by the CNI server as we create pods. And so it's just matching the destination MAC address to the desired destination port, sorry. And one thing to notice here is that we are not calling the output action directly. We're just like loading the port number into register 1, which is the second OVS register. And that's because we haven't, that's because we haven't enforced ingress rule tables at this stage yet. And why do we put the ingress policy rules after forwarding? It's because we want to be able to match on the port when we enforce the policies. So we need to have computed that port.
So we are basically here, we are just, it's called L2 forwarding table, but we are just assigning, storing port numbers into registries. That's the only thing that we are doing, right?
Yeah, based on the MAC address, on the destination MAC address of the packet. So now, same thing, I'm gonna go over this quickly. This is just the counterparts of the egress tables for ingress policy rules here. I think one thing I didn't cover previously, so maybe I just talk about this, is we do install a high priority flow using contract that says that this is not a new connection. just accept the traffic. Don't perform the whitelist checks again. Just accept traffic. I think this has a behavior, and I don't know if it is the intended behavior. So if somebody knows, I think please bring it up. Which is, if we have an established connection, like a long-lived connection, and we update the network policy in such a way that this connection is no longer valid, then we're not going to enforce the network policy right away. And so is this documented anywhere in Kubernetes that this should be the default behavior?
It's not. It is a behavior that is not explicitly specified by Kubernetes API specification. I think that we had the same questions in the past, and we checked the documentation, and it was not strictly enforced, the behavior. As a matter of fact, in my opinion, the behavior that we are implementing right now is not the right behavior. Because one can have like a connection, keep having doing a keep alive with it for it, doing a keep alive for that connection every 10 seconds, and that connection will probably never be forever then there, and therefore you can deny it by a policy, but that deny action will never take effect on your connection. In my opinion, enforcing a policy also means breaking existing connections. But this is just my interpretation on the semantics of network policies. So I think that it is subjective, and it can probably vary also from, use case to use case, from situation to situation.
And actually, I was very curious is if this was the reason why we added this flow. I'm thinking the reason is because maybe in IP tables-based solution, being able to use contract for this means that things are faster, basically, because you don't have to walk through the IP tables rules.
My understanding too, yes.
But the fact is, for OBS, things are completely different, because those flows are going to be part of the flow cache in the kernel data path, right? Either the exact max cache or the mega flow cache or whatever. And so, like the way those flow caches work with contract, that's a bit more involved, right? And so I don't think this, my opinion, my guess is that this doesn't help with throughput most of the time, and actually makes things a bit worse, because now we essentially have to call contract for every connection and keep like stateful information about every connection, which uses memory. And I guess somebody could just like create connection and blew up the connection table for no good reason.
There are pros and cons. You might see also a comment that that if you don't use contract, then you will be evaluating these flows for every single packet and not on a connection basis.
Yeah, but today, what happens because of this is the packet goes through the flow table once. We decide that we have to send it to contract, and that happens for every packet. Then we get the contract state, we get those flags, and then we have to apply the packet through the flow table a second time. There is basically like a recirculation happening in the kernel data path. And so I think we may actually get worse performance by using contract because of this. That has to happen for every packet.
That is something that is definitely worth evaluating. And in my opinion, whenever I see a flow like flow 1, it makes me want to try to find a way to hijack this condition, like spoof something so that I can make a new connection look like existing connections, so that I can get a free pass. But yes, you're right. As a matter of fact, that is probably a valid concern.
By the way, other CNIs have this exact same problem. Calico has this problem, for example. So you have to break a connection and reestablish it if the policies are changed. The connection state keeps the previous policy in place.
Yeah, and that's because the performance boost that you get from IP table when using IP tables by doing this is probably non-neglectable. But I think
correct. But here it may be different. Yeah,
for OBS, I don't think we get any boost, and actually maybe the reverse effect. And so, because these flows here are the one reason why we use contract for all connections instead of just the very specific case I described before for rewriting the destination MAC address. And I think we have probably a significant overhead for every every single packet that goes through the switch now. So I'll take the action item to open an issue. And I mean, I agree with Salvatore. I think maybe if it's a differentiating factor, the fact that we have that different behavior for network policies, it could be a good thing as well.
I mean, to me, like, you know, from a semantics perspective, it looks more correct to me that if you have said that a connection is not allowed, that applies to existing and new connections, right? But anyway, so we can experiment that. I am a little bit curious about the remaining flows, so maybe we can move forward with the analysis.
Yeah, sure.
No, the analysis of this table. Sorry,
oh, sorry, yeah.
we just did the first rule here.
Well, it's very much the same as for egress.
There is one difference here is the ports are different for the destination.
Yep. Yeah, that's correct. And I didn't put the rationale here, but it seems that the rationale is that it's kind of like an added security measure to prevent like using spoofing, IP spoofing to bypass a network policy rule, is how I understand it.
But reg1 is the one that we loaded in table 80?
Sorry?
Reg1 is the one that we loaded in table 80 with the port number?
Yes, that's correct.
Okay.
So that's the destination port. So that basically identifies the pod we apply the policy to here. I mean, the rationale for using port and the IP address here, I believe, is that let's say you have two local pods. So for those local pods, we're going to do L2 switching. We're not going to do L3 forwarding. So in theory, I can use the destination MAC address, if I know it, of a pod I'm not allowed to talk to, just by putting an IP address here that's going to make it bypass the policy. So there was like kind of like a security thing going on here. And since we could use the port here, we decided to use the port.
Okay. And the flow number 8 instead?
That's just a conjunction action here.
No, this is a resubmit action, but it matches on matches on the conjunction conjunction, right? And then it resubmits to table 110.
Yeah, which
so
is the
means
last
that
table of the pipeline. Yeah.
It means that if conjunction number 1 is satisfied, go to table number 110, right?
Yes, which is send the packet out of the port that was computed by table 80.
Okay.
Oh, this is the last. This is the end of the pipeline.
The reason why I was asking it is that I see that there is IP everywhere. So for instance, in that flow, we are matching on the conduction action, and we are also saying IP. Is that important, that thing that we say it has to be IP traffic? Because if we match that conjunction action, it has to be IP traffic. We already have verified it, right?
I know also why we had IP. It's not a good reason. It's just like we have defined an API to build flows, and this API basically adds IP by default. So
okay, perfect. Because I'm asking this because I'm thinking about IPv6 that has a different match. It's not IP, it's IPv6. And you know, if we had to use that, I will have to create another flows for IPv6. But if that is like redundant, we'll just not match on it, and we'll still use one flow.
Yeah, I agree. I can write that down as well and see if we can send that. Yeah. There is no reason. We know at this point that traffic is IP anyway. Every other traffic has been dropped at that point.
Cool.
And that's probably a change we'll have to make also for IPv6. Okay, so I think that's all for me. The last table is pretty basic. We just output to the correct port where the value is read from the register.
Okay, perfect. Sorry, one stupid question about table 100 and table 110. Why do I see drop everywhere? Whatever we do in 100 and 110, we drop the traffic.
Here?
No, okay, so no, sorry. The way the table where we actually forward the traffic is the flow number 1 in table 110, right?
Yes.
And in any other case, it's dropped. Okay, perfect.
This is just enforcing isolated pod behavior, just like we covered for egress. Yeah.
Okay, so one thing that I noticed is that we are pretty much redefining, overwriting the default switching behavior of Open vSwitch. So we are basically never using the MAC learning feature or the basic forwarding features. We are always enforcing layer 2 forwarding as well, right?
I don't think that's correct. I think for our packets, we use a normal action, and I believe there's going to be like a separate MAC table for that with MAC addresses, which are going to be learned.
Okay, so but when network policies are enforced, we don't use the normal action, right?
Never. That's correct.
Okay.
Yes.
Okay,
And
perfect.
our MAC address, as I mentioned, is not populated by learning. It's populated statically as we create pods. We add entries
Okay,
to the destination
cool.
MAC table. Yeah.
Okay, so the only other question that I have is that do you think that it would be a value in enhancing the ARP responder to have an entry for every pod so that basically we pretty much stop sending every sort of ARP request over the switch, or do you think that any sort of performance or throughput gain will be pretty much negligible?
I think it's all negligible. We don't send that traffic across the tunnels anyway, right?
Yeah, it just stays in the node. So I too agree that I don't think there is a lot to gain. Okay, cool. All right. In terms of general networking behavior, do you think it might be worth completely banning some protocols like DHCP, for instance?
I don't really have an opinion on that. Wait, so DHCP, is that on top of Ethernet or is that on top of IP?
DHCP is a layer 2 protocol.
So it's going to be dropped anyway. It's all
Okay.
banned.
Yeah, that makes sense. That makes sense.
Traffic has to be ARP or IP at this stage. Yeah.
Okay, cool. All right. So is there any question regarding the OVS pipeline?
I have a very basic question. When we have a flow to allow traffic from, let's say, IP dot 1 to dot 2 or dot 2 to dot 3, do we also need to add a flow for the return traffic, or these are stateful flows?
So yeah, that's a good question. I mean, maybe that's why we use contract as well. Actually, yeah, let's think about it a bit. Right now, for the return traffic, it's gonna eat like the contract entry. And so the connection is established and we're just gonna accept the traffic. So that's taken care of. Now, if we remove the contract entry,
yeah, then we need to.
What's gonna happen exactly for that?
Yeah, maybe we can think about it when we probably open an issue for the contract with network policies.
So if maybe it's a question for you too. If I have two pods like pod A and pod B, and I define a network policy such that pod A can send egress traffic to pod B, but pod B has an egress traffic that says it cannot send traffic to pod A. In this case, pod A can still connect to pod B. So that means like all the reply traffic should be accepted. Is that correct? Or
I think that's the expectation.
So it's really about instantiating connections.
Yeah.
In that case, we would definitely not be able to remove the contract flow easily.
All right. I don't want to sound annoying, but perhaps this is a conversation that we can take to the project mailing list, and or maybe on GitHub. And I would like now to quickly move to the 0.20 release status. We have 6 features still open, like 6 issues still open. I think that one of those is just for documentation, which is pretty much is what Antonin just showed us today, right? This one over
Yes,
27.
this will be closed when I add.
Perfect. Then in terms of features, we have Kubernetes network policy implementation, where the two remaining issues, as we discussed the last time, are more pertaining testing. So let's say that the feature work for it has been implemented. I believe that we still need to take care. No, we did take care of the accept block, right? That one was done.
Yeah, there was one patch in review. I think that looks. I don't know whether it was merged yet or not. Maybe it was merged last night.
I think that otherwise it would be tracked here. Yes, it's been issue has been closed. Perfect. And regarding the CLI, unfortunately, this is where I have not been able to check the progress for the Antrea CLI. I think we have two PR closed, one PR is still open. Is there any one of the people on the call reviewing this PR?
I think Janjun has been reviewing, but is on his way to the airport right now.
Okay, so we'll check the status after the call for this one. And regarding the conformance tests, I think that Johnson is working on it, and I believe that we got a success. We got a success right now. Yes, is that correct?
For network test, I think so. For network policy test, I'm hoping that apart from the named ports one, everything is passing, but I'm not 100% sure.
Yeah. Okay. We said already that.
There were some other issues actually. We didn't tag it for the release yet, but I think Chan observes that sometimes we take a while to enforce network policies.
We have yes, we have an issue open for that. It's 197, I guess.
And I believe that it is causing some of the tests to fail. Yeah.
Yeah. Okay. Yes, I noticed that issue indeed as well. And yep, that's something that perhaps we may want to address. And in terms of documentation, I mean, the other thing about this IPAM thing, we already discussed about it. So I don't think that there is anything else that will need to be discussed. We just need to verify the status of the CLI. And then for the issue with this delay in network egress, which is 197, I have a note from Janjun that says that Abhishek has an idea for it, right?
I think, yeah, Chan has already added the comment, but it's
okay.
Basically, I think
Kubernetes updates their status to Kube API server. We can rely on the CNI event to trigger the enforcement earlier, as the required data for policy enforcement will be ready after CNI add is processed. Okay.
So what does that mean, Abhishek?
So essentially what is happening is that the pod might come up and by the time the API server...
I read a new channel. We can use a channel, but I think it's just talking about a Golang channel, not like not like a new TCP connection to establish. Okay, I'm just thinking, whenever we talk about the CNI add, we know that CNI add works for when new containers are added, but it doesn't work for when we apply a policy on existing containers. But we also know that we have another problem in that case, which is, if the connection is already established, the policy won't do anything in any case. So it is okay to worry only about the CNI add case, I guess.
Yeah, for existing, I think policy, the flows will already be
okay, so we'll check with Chan if this is something that we can target for 197. Because since it affects, sorry?
You mean the release? You mean?
Yes, because since it affects the end-to-end network policy test, then we might want to fix it. I understand that, for production use cases, this is not probably a super massive issue, at least not at the moment, but it would be nice to address to make sure that the end-to-end network policy test pass. All right, so is there anything else you would like to bring up for the upcoming release? Any other issue that we might need to discuss and we haven't yet discussed?
Yes, there is an email I sent to your agenda thread.
Yes.
And
I
know Dungeon talked about this issue, but I don't think it's as important as this.
This is the one that you want to talk about, right?
Yeah, so I opened it like a while ago at the very beginning of when we opened for Antrea, but basically it's like an important issue, which is, and there was an issue open for support a while back, and clearly there was no possible action on our part without getting like more information about the cluster and more logs from Antrea and maybe kubelet. And so basically is how do we make it easy for people to gather that information so that we don't have to ask every time, please provide this, please provide that. Instead, they can just like put a tarball somewhere that contains everything we need. And I think the first step is to maybe talk about what we think we need before we start discussing the process of collecting that information.
Which is exactly the same thing that we have with the Prometheus integration. We need to define first what we want to collect, and then maybe we can discuss how we want to collect it. So I completely agree with you. And in my opinion, what is really important here is apart from, of course, from Antrea logs, are the kubelet logs, perhaps the kube API server logs. I usually never find kube scheduler logs useful, typically. And another thing that on which I am not certain about how it works with Antrea is the CNI logging. I noticed that the CNI plugin is not logging into the kubelet log, so it's using a different stream, right?
Someone can correct me, but I think it's part of the kubelet log.
Okay, I might just be confused because normally it's the kubelet log. I thought it was somewhere else, but if it's the kubelet log, then we have nothing to worry about. And then we need to collect the current cluster status. I was thinking initially we just do a dump of etcd, but I don't think this will fly, right?
I don't know. I guess what are secrets in etcd, not in plain form, right? And
sometimes they're just base64 encoded and they are protecting by airbag, so they're not necessarily encrypted.
Yeah, also that may be hard for us to really like consume that information, to be honest. So
so I think that it might make sense to get a detailed YAML output for namespace list, pod list, and network policy list, and perhaps service and endpoint, even though being now as we now interpret as we now are doing that through kubeproxy, maybe service and endpoints are not strictly useful, but I will collect them. And of course, another thing that is important are the kubeproxy logs, and then the kubeproxy config map. And then I don't know how we want to capture configurations for kube API server and the kubelet, because I think that the configuration files also tend to contain secrets there. So I don't know if it's okay to just upload the configuration files.
Maybe Cody and Yasin have some insight on the kind of information that's useful for somebody raising like a support ticket, especially when the cluster becomes large.
Well, I certainly agree with Salvatore that we don't want to upload any secret information. Is there anything specific in the kube API configuration that is impacting our network configuration other than things like service sitter ranges and those sort of things, or can we narrow it down to the 2 or 3 specific things that we need, and then maybe just be able to parse that configuration and extract the exact things that we need out of it?
Yeah, I mean, for me, from the kubelet configuration, for instance, we only need the flags that are used to start the kubelet. I don't think that we need anything else.
Right.
Then there are other information that I would like to collect on the host, which is, for instance, OVS kernel module, which could be always useful to have. Sorry, the OVS kernel module version. Whether, for instance, now with Kubernetes 1.18, it will also be important to understand whether IP tables as the standard implementation or the NF tables implementation, because kubeproxy will also support NF tables.
Right.
Another information that could be useful is the container runtime, and will be just mostly for reproduction efforts. So we need to know which is the CRI driver in use, or whether they're just using Docker runtime. And it will be basically pretty much there are just 3 runtimes, I think now. They're Docker, CRIO, and containerd. So we just need to know which one is running, which version is running. I don't think anything else will be used. That's pretty much it, I guess.
Yeah, the other thing you mentioned, IP tables or NF tables. One of the common things I would see with other CNIs is there would be rules that were specified by some other engine, right, that were interfering with the with the policy, with our policy engine, right?
So perhaps a
so
dump
we would probably get a dump. Yeah, a dump of IP tables or other enforcement mechanisms would be useful.
Yeah, and speaking of dumps, of course we need to dump OVS flow rules, right, Antonin? I think that makes sense, right?
Yeah, I agree. I'm just afraid that for big cluster, all that information per node information is going to be quite large. But
it's going to be quite large and dispersive, but this is how we root cause issues. Looking through gigabytes of logs, unfortunately.
I'm pretty sure that the issues we're going to get at first are going to be for small 2-3 node clusters.
I don't know if it makes sense for us to collect OVS logs too. What do you reckon?
I sometimes look at them, the Open vSwitch daemon logs at least, not the OVS DB logs. So, I mean, these are going to be smaller than the table. So.
And shall we just ask for an OVS flow dump or also for a DB dump?
I think flow dump is enough. But
I agree. No, I agree, because we don't do any. We pretty much don't do any operation on the DB server, right? We just manipulate flows.
Yep.
Okay, so maybe
we add ports and configure ports for those.
So perhaps we can collaboratively add all these items to the issue here, so that we can try maybe by the end of the week to have a full list, so that we can start operate on it.
We've only got 2 minutes left. I did want to just, and I can reserve this for the next meeting. I wanted to at least propose the idea from a documentation standpoint. If we would think about using something like read the docs, or if somebody has a better idea for a more structured output and have like a docs.antrea.io site that would be very targeted for and structured for determining who the consumer of that was going to be, whether it was going to be a contributor or an end user, to be able to very quickly get at the information they need to either set Antrea up as an end user, or be able to dive into some of these deeper things like the flow diagram that was shown today. Any thoughts on that, on setting up a structured documentation site?
I would love to do that, but I'm afraid that I'm not sure if we will find time to do that in the short time. We should definitely plan for it, and we should probably have a sort of let's say, a timeline for how we plan to roll out this documentation. Because of now that the project is still fairly young, it might be okay that that might not be needed because most of the users are also contributors. But yes, we definitely start getting users. And I think that we should plan maybe by end of January to have this site up and running. Like, read the docs will be good enough for me.
Absolutely. I'm not thinking like tomorrow or anything like that, but it's something that I wanted to go ahead and start putting together some proposed structures and getting the feedback from the team as we start thinking about how that should look.
I would love if you could take that action item. That would be
Absolutely
incredibly great. All right, so we agree that Cody will start looking at the structure for the documentation for a doc site, and then we'll work together to putting the contents there as well.
Yeah,
and
just a thought for what it's worth. I personally like to keep everything on GitHub, and I think a lot of projects are using Jekyll now to just generate a nice looking website from Markdown files. Because I mean, I think it's easy for me to just write documentation in the form of Markdown files, but so I don't know.
Yeah, I think read the docs is pretty much still Markdown, right?
It is, and it's tracked in GitHub. You can the one thing, whether we use Markdown or not, it really we can debate that and decide what the best solution is. I think the key thing here from a user perspective is we just want an easy way for them to switch between active versions of the docs, right? So what were the docs at a specific version in the past versus what the docs are now?
Yeah,
so that if
it should be versioned on GitHub, definitely. Yeah.
Absolutely.
Okay, so I think read the docs might be RST, not Markdown. But if it's not read the docs, is whatever is that it uses Markdown, that we can keep the documentation in the repo, so that we manage it like with pull requests and whatever. Then we have a make action like make doc that automatically publishes to whatever site we're using. I've been using Jekyll in the past too. When I've been using it, it was very immature. So, but maybe it's much better now. Anyway, so let's start with giving it a structure, and then we can decide together on where to publish and how to publish it. I agree about not using two distinct markup languages. Markdown for everything should be good. All right, it seems that we are at time. So is there any final item that you would like to discuss?
I'm good.
All right, so the items in the agenda that were not discussed today will be deferred to the next community meeting. Speaking of which, I was planning to have one final community meeting before the New Year, the end of year break on next Wednesday.
Yeah, we need 2 more weeks anyway. Yeah.
And then, then the other 2 Wednesday will be Christmas and New Year Day. So I think we'll skip those ones, and then we'll meet again on January the 8th.
Yeah, so, we should finalize the release next week.
That's right. So that will be next week will be the last meeting of the year, and then after that it will be the 8th of January. All right. So thank you very much for attending, and it's been a pleasure as usual, and talk to you next Wednesday. Have a good one, good afternoon, good morning, good evening, or good whatever.
Thank you. Good night.
Thanks.
Bye-bye. Bye.
Bye-bye.